Hello everyone, this is Prasad. On behalf of Unacademy, I welcome you for another session on hybrid electric vehicles. In today's session, we are going to understand the eDrive system, motors, inverters and controllers. We will be dividing this session into number of sessions because in a single session, it will be difficult for us to understand all these concepts. As this is most important topic, I request all of you to be completely attentive and note down the important things. Before this, we have understood many things and we have came to know how the powertrain is designed. We have understood what are different forces that are acting on electric vehicle, how the powertrain equations are there. And today we are going to go further and understand eDrive system and its overview. So there are many contents of this further lectures, 4-5 lectures which we are going to have on same topic. And it includes the introduction, the selection of electric vehicle motor, because all of you know there are different kinds of motor available. We are going to understand characteristics, features, specifications of every motor. What are different electric vehicle motors and the comparison of EV motors with the industrial motors. Then what are basics of electric machines. Then what are electrical motors, their introduction, their classification, DC motors, AC motors, evaluation of EV motors, 4-quadrant operation, motor control unit, sensors, inverters and control, and finally we'll be understanding simulation softwares. So this is a very extensive study of eDrive system. So let's start the session and quickly first of all revise whatever we have understood till now. We have understood that hybrid electric vehicle is combination of conventional IC vehicle and electric vehicle powertrain. So it has various components including motor, battery, controller, DC to DC converters, onboard chargers, and also some of the components which are from IC vehicle like engine, fuel tank, alternator, carburetor, exhaust system, etc. Also, we have understood that there are different configurations and components of hybrid electric vehicle. We have understood the block diagram of hybrid electric vehicle, and further we have already covered how you can have different configurations of electric vehicle and hybrid electric vehicle. In case of hybrid electric vehicle, we have understood that there can be a series hybrid electric vehicle, a parallel hybrid electric vehicle, and we came to know that every configuration had some advantages and disadvantages. The parallel hybrid electric vehicle configuration is mostly used for hybrid electric four-wheelers, and the series hybrid configuration is mostly used for the buses and trucks which are hybrid electric. Also, we understood the P0, P1, P2, P3, P4 configurations, and we understood that P0 and P1 configurations have direct connection of motor with the IC engine, whereas P2, P3, P4 configurations are not having direct connection of the IC engine with the electrical motor. Then we understood what are the different components of electric vehicle powertrain. We have understood that there is a charger. If you want to do fast charging, you have to have the off-board charger. If it is normal AC charging, then on-board charger takes care of converting the AC into DC. Further, that DC is fed into battery and the energy gets stored in the battery, which can be used by motor to run the vehicle. Meanwhile, in between the battery and the motor, we are having some power electronic interface, which can be called as a converter or inverter. In generalized term, it is called as inverter because it is converting DC into AC. But we are considering the regenerative braking feature also. The power has to flow backward also. That means it has to convert AC into DC also. For that case, it has to be bidirectional. So, moreover, it is called as converter. Now, it is time for us to go ahead and also understand, and quickly we should have recap of the powertrain. We have understood there are two different voltage levels in case of hybrid electric vehicle or a conventional electric vehicle powertrain. That is, one is high voltage and other is low voltage. Low voltage is used for auxiliaries and high voltage is used for powering the electrical motor. Going ahead, let's understand the eDrive system. eDrive system is a heart of electric vehicles and hybrid electric vehicles that generate the propulsion torque over a wide speed range. We have understood that in case of IC engine, it is efficient only in narrow region of operation. It is most inefficient when it is at idle condition. The vehicle is not running, it is not moving, but the engine is on. For example, you are standing on a signal, there is a red signal, so you cannot go ahead. In this case, if the IC engine is in on condition, then it is most inefficient. So we have understood that there are few hybrid electric vehicle advantages, like you can operate the IC engine in its efficient mode of operation. But if you consider the electric vehicle powertrain, the heart of EVs and HEVs is nothing but electrical motor that generates the propulsion torque over a wide speed range. So electric motor is having capability of providing the torque and speed over the wide range. So it all in all, if you consider all the important components of eDrive system, then it has electric motors, it has power converters, and it has controllers. Now, I hope all of you know electrical motor is the component which is converting the electrical energy into mechanical energy. Power converter are converting DC supply from the battery to three-phase AC for most of the hybrid electric vehicles and electric vehicles, because the motors which we are using for propulsion are mostly three-phase induction motors. Also, there are few converters which are making sure that the DC voltage is available at lower voltages so that the auxiliaries will also run. So here, mainly as we are discussing the drive system, we have mentioned that power electronics is the system which converts the DC supply from battery to three-phase AC and supplies the motor proper voltage and current. As per the requirement of motor, the power converter should be capable of converting the DC into AC with required voltage, current and frequency. Also, if you see motor, as I told you, it converts the three-phase electrical energy into mechanical energy to propel the vehicle, or vice versa during regenerative braking. As we have understood earlier, if there is a slope, okay, or if you are going downhill, or there is enough momentum that you have got and your vehicle can move ahead with that momentum, then you don't need to accelerate. In this condition, the electrical motor acts as a generator, and whatever energy is being captured from the wheels in form of mechanical energy, that's converted into electrical energy. So the motor should be also able to operate in the reverse mode as a generator, and three-phase induction motors are most efficient in this case. So the controller, further component, the controller, it controls the motor and inverter to obtain desired speed and torque characteristic. Now further we are going to understand speed and torque characteristic of each and every motor. We are going to understand detailed classification and what are different speed torque characteristics for a different motor, and how to select the proper motor for electric vehicle. So controller, what the controller does, it makes sure that it controls the motor and also the inverter to obtain the desired speed and torque characteristic. Like we know, during the beginning we require a little bit of higher torque at lower speeds, and as we go ahead with the increase in speed, we have understood that for IC engine most of the time the reduction in torque happens, but with the case of in the case of the electrical motor, there is possibility that you can have good torque over a good speed range. So controller has to take care of this, and it has to provide the required speed and torque, okay, as per the need. Now let's go ahead and understand the further details. Before that, if you see this little bit simple diagram on the right hand side of this slide, it is a combination of motor and controller. Already we have understood the batteries. Batteries are nothing but what you can say, I say them as a heart of electric vehicle, because whatever energy the motor, the controller, everything, whatever energy is coming from, it is coming from the battery. Already we have discussed the batteries. So here that whatever you are seeing on the right hand side is the motor along with the controller. And if you want to understand the block diagram, here you will find at the center we are having power converter which is connected with the battery. Of course, there is a bidirectional power flow between converter and the battery. Then we are having an electrical motor, and the power converter has to take care that whatever requirements of motor are there that are fulfilled, and the requirements mostly in terms of voltage and current, As the battery is having DC voltage and if motor is AC, the power converter has to take care of converting this DC into AC. In the reverse power flow, that is in case of regenerative braking, when motor acts as a generator, the power converter has to convert the AC into DC.